We're going to be talking about APIs this morning. And I can't, so can everyone see this whiteboard? All right, cool. So let me kind of like go through this here. We're going to talk about APIs this morning. It's going to be an introduction to APIs. It's going to be a high-level overview. This material in this morning's class is not going to be something that you're going to use or be tested in Module 2. It's going to be an introduction so that you are able to speak about it, and it's kind of your first exposure so that come like Module 3, it's not going to be the first time you've encountered these topics. We are going to use this whiteboard because I just got this tablet, and I figured this is a good way to kind of see how using this whiteboard in Zoom works and see if this is something you all like. So like as we go through this, would very much like your feedback. Like, did you like having this whiteboard here? I think personally I missed writing on a whiteboard, and hopefully, I think that it's a good way to kind of like have things up on there and be able to draw diagrams for you. So again, like, please, just like any feedback you have on this, on how this works out, would be greatly appreciated. So, APIs. What's an API? Big picture, like, what is an API? What is an API in the context of web development? Just anyone would like to raise their hand and talk about it. It's perfectly cool. Ryan, what do you think?
APIs are like our connection to other people in the web work. Like we can talk to Google and get their maps, or we can talk to Twitter and get something that they've built and work it into our own program. What have I heard said? Standing on the shoulders of giants.
Yeah. Oh. Okay, so are there buttons on this thing and it does not like me? Talking to other things on the web. Yeah. I think that API is how like things can communicate across other things on the web. But what about in general? Like, what about not in the context of web development? Ooh. Daniel.
Aren't they kind of just like a bunch of data from a different company that you can use within your application?
Data? Data's one way to think of it. Like, yeah. Also, in case you are missing out, like missing the experience in class, this is how my writing also looks on the whiteboard. So no judgment, please. When we think about APIs, I want you to understand is that like along with all of what we said in the context of web development, it's also important to think that it is a very contextual term. API stands for application programming interface. It is very hard to write when you can't actually see like what you're writing on. So like this is like the tablet, so I can't actually see what I'm writing. So it's like a best guess as to what appears on the screen. And I think a great definition of how we can define an API is like an API is a set of rules in that we interact with something at a basic level. So and I'll give you an example of this. Like you've probably seen in your rubrics from module 1 where we talk about things like the rubrics probably says something like understand Ruby API. And like thinking about the concept that we said, like how, like when we when we think about it, like what does that have to do with the web when you worked in module 1? Like we talked about how the APIs, like how we interact with other things in the web. And yeah, like the interaction part is what's important. And so when we think about the Ruby API and we say you understand how to use the Ruby API, what we're saying here is like, hey, you understand that like when I want to get Ruby to do something, you do this. For example, we have the puts method. How do we use the puts method to print something out to the screen? Let's see who makes eye contact. No, Daniel. Daniel's chewing.
I'm also eating. Wait, me?
Yeah, I picked it because you were chewing.
No, there's 2 Daniels now.
Oh, sorry.
I get confused now. So to use puts, you just write, I don't know, puts.
Yeah, but what comes after the puts, right?
I don't know. What else do you want?
I mean, what comes after the puts?
Oh, and then you put in like, you could put in strings like hello world or something like that. Yeah.
And that's like a very basic example of like the Ruby API. Like we understand that when we want something printed out of the screen, we have the puts method, and then we send to it an argument of whatever we want to print out of the screen. In this case, it's a string. Geez, I'm sorry, I just saw the chat and that's amazing. A string, array, some kind of object, and it'll print out to the screen, right? When we iterate over something, right? We do like collection dot each do the pipe thing blah 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 end, right? This is the Ruby API. And so like I think it's very important for us to understand that APIs live in a world, not just the web. There was this lawsuit pretty recently. I think it was between Oracle and Google based on the API. Like Oracle had made this method that I don't know the details, but Oracle made this method that took certain arguments and did a certain thing. Google, in I think the implementation of Android, used like the same method name, and it took the same kind of arguments and it outputted like the same thing. And Oracle sued Google over the saying like this is a violation of intellectual property rights. And Google's like, we just kind of like, we don't know what's in your API, but we just may do the same thing. How is this an inflection of intellectual property rights? I think the analogy they kept using, it's like a recipe to a hamburger. Like you might make your hamburger differently, but like you still use bread and meat, and we just use bread and meat, and we still got a hamburger. And it was like a really kind of like fascinating case. And I think the particular thing about this case I thought was really fascinating is that the judge actually taught himself how to program so he could rule like objectively on this case. And like he was discussing technical things in court, and I was like, that was actually kind of impressive. I think above and beyond. So that's APIs from like a big kind of standpoint. Why do we want to learn about APIs in a web context? If APIs are just data, like why I don't care about your data. What if your data is garbage? Why do we think that we might want like someone else's data? Let's see. Let's pick from the rogues gallery. Anyone chewing? Stephanie. I'm sorry, but this is just fun for me.
I like took a bite right when you said that, and I was like,
Why do you think that we might want data from somewhere else?
Well, it's helpful to know what we're building with data that provided.
I mean, like, but I can make my own data. Isn't that better? I made it.
I suppose that's maybe true.
No, I see.
I mean, just because you made it doesn't mean that it's the right data.
Very fair. Alex, I saw a hand there.
Yeah, I mean, right now we're working on a project where you have to share data between two people. So I think we have an example we're working on.
Brian?
I'm lazy. I don't want to make something that's already made.
Exactly. Laziness is totally true. Steve?
Well, like for instance, like Google Maps, I don't have the resources to go out and like map every business that exists in the world.
You sure?
So I'm not going to do that.
Are you sure?
Pretty positive.
Okay. Alex? Is that hand still up or is that?
Oh, sorry. No. I'll take it off.
Okay, cool. Yeah, and like we might want to use data from somewhere else because like they're experts. I think a great example is like, let's say in your adopt don't shop projects, like what if you wanted to weather? Like do you want to like stick your head out the window every single time someone goes to your website and let them know what the weather is? That sounds like a terrible idea. But we can leverage like a weather API to kind of do that. I think that this kind of goes to this example of that, how we talked about previously. And when we diagram how a web app works, that's a laptop, by the way. This is our server. And we send this HTTP request to the server. The server then hits the routes and the controller. And what does the controller talk to next to get information? Just anyone.
A model.
Yep, and the model, what does the model talk to?
Database.
Yeah, so this is a This is a cylinder. Cylinders are generally the symbol used to denote a database. And a database will usually have information and our database lives somewhere else. But the idea here is that instead of hitting our own database, like we don't have that information, what we can do is that we can go to, this is a cloud, and the internet. And this internet, this API somewhere lives somewhere on the internet. We'll have that information and send it back to us. I think weather is a great one that we have an example of. The next API class, we're actually going to consume an API. We're going to show you like how to reach out to the Star Wars database and like look at Star Wars things. I'm a person who has ideas and buys domains for them. So I am the owner of HogwartsAPI.com because I'm going to, like, once I get around to it, I want to make a Hogwarts API. Ryan?
Yes. Does the API also go through a model? Like the database goes through the model to do the thing? Like, are we also like leveraging Active Record and the model to go through an API and then serve us objects back?
Not Active Record, because
Okay.
Active Record is how we interface with the database.
Uh-huh.
We're gonna do things that are very similar to what Active Record does, but we're gonna make it ourselves.
Gotcha.
Cool. So, and this is just one kind of example of why we'd use an API. And another one is like, I think, what are the two programs here at Turing?
Front end and back end.
Front end and back end, right? I mean, those are two separate things. And the idea here is that the front end is completely like kind of like back end less, and it just depends on these APIs for their data. And so when we think about APIs, when we're building an API, who are APIs for? Anyone have any thoughts, or we pick a volunteer?
Users or other applications?
Not you. Like so when we think about it, like, are you consuming an API directly? Are you just going to look and like just give me data?
I mean, like a user, as in, I guess user was the wrong word. The browsers or whatever service is connecting to your API.
Yeah. I think that we think about it like we want to think of like a client. And the thing here is that the primary consumer of an API is not going to be a user and like not a human. A human, what a human does is that when we look at data, we need it on a web page that's structured. Maybe there's a picture, there's a big header information here. It's got to be presented in this very kind of human readable way, right? And what in our Rails application makes the information that we're getting from the database like superhuman readable? Colin, what do you think? Are you talking? I did not hear you.
Can you hear me now?
Yeah.
All right, cool. You were asking, what was your question again? You were asking what?
Yeah, so when we are viewing data with our browser on a web page, what makes that human readable? What gives us all this fancy stuff?
The HTML and the view.
Yep, HTML. And what's the other half of the HTML?
The view.
What else? No, what else does the view use to make HTML pretty?
ERB.
Pretty.
Oh, CSS.
CSS, right. Yeah. No, that's right. And so, like, the thing is that, like, if our API is going to be working in a way that gives, like, that lets us just have information and someone else's response for that, we want the stop. We want this data to be as light as possible to travel for. Like the main consumers of APIs are going to be other computers. What do you think is the most efficient way for two computers to talk to each other? Zach.
I'm not sure what your question is.
When two computers talk to each other, like what's the most efficient way for them to communicate? When one computer talks to another computer, do they need HTML?
No, I mean everything. I mean, I remember you guys saying everything's passed via strings.
Right. And HTML is essentially a string, right?
Yeah.
But does a computer care about how pretty your page is?
No.
Does it care about the styling?
No.
What does it care about?
I mean, the headers. I'm not really sure.
Yeah, like the information, right?
Yeah.
Yeah, right. We care about the data, and so like one could possibly say that the most efficient way for a computer to talk to another computer is like, what if they just talk through pure binary, right? 0. Oh God, stop. Yeah, technical difficulties. Thank you. 0s and 1s, right, is the most efficient way for computers to talk. But what's the problem with 0s and 1s if like something goes wrong? Kelsha?
I don't know.
So can you read 0s and 1s?
Oh, no.
Right? So like if something's wrong and two computers are talking to each other and there's a problem with that, it's very hard for a human to kind of interface. But at the same time, when we look at the other side of that, like HTML, CSS, like that kind of information is going to be very easy for a human to read, but it's a little more than a computer needs. So we need to find some kind of balance between the two. something that's kind of lightweight, but it's something that also humans kind of need can look at and understand easily. And that's where JSON comes in. Important things about JSON. Number one, JavaScript object notation. 2, it's a string. And the idea that is that it can hold various types of data, such as numbers, strings, hashes, arrays, booleans, nulls. Nulls is like a nil, but it's a null. No, wait. Null's like a nil. Let's put it that way. Oh, we already said hashes. So scratch that out. And the thing to note about JSON objects is that they're almost like a Ruby hash, in that it's very much organized into key value pairs. And you are familiar with working hashes, so this is going to be something that is easy for you to kind of like understand going forward. I want to note that most, if not all, modern programming languages have a JSON library so that you can work with JSON objects easily. Like, it is modern. It is, I would say it is the most common language you're going to use in working with APIs in the future. Not common language, but like the most common format. And it is a subset of the object syntax in JavaScript, which we'll learn later on. I want to note that when working with JSON, you'll never work with JSON directly. What you're going to do is that you're going to take that JSON object, you're going to convert it to Ruby hash, do whatever you need to do with it in Ruby, and then if you need to convert it back to JSON, you do so then. Questions now to this point about JSON and APIs? Tyler.
Where does this JSON info live? Where is this?
Say more about where does it live?
Where does it exist? Like, what is?
Yeah, so let's take a step back, right? And so let's say your Adopt Don't Shop project, you decide like, hey, I'm going to include weather on it, right? So what you do is that you'd essentially reach out to a weather API, and let's say you're in Denver, and it's like, hey, weather API, I would like you to give me my weather information back for Denver. The API server is going to, do whatever lookup in its database, whatever, grab the information, convert it to JSON, and then send it to you over the API. Send it to you through the API over the internet, and now you have this JSON object, which you will then convert to a Ruby hash, and then pull that data out of and incorporate that on your web page. Does that answer your question?
Yeah, that does. Thank you.
Cool. Jordan and Brian?
Mike, can you hear me okay?
Yeah.
At the beginning of your explanation on JSON, I didn't quite get the full definition. I got JSON is used. Do you happen to remember what you said about it? Like how I'm trying to remember exactly the context, but
yeah, JSON is used as like the information format in which computers talk to each other over the internet.
Perfect. Thank you.
I want to mention that like JSON is not the only format. Like there is XML is another one. I would not wish that upon my enemy. It is kind of like gross and not that fun to work with. Brian?
So typically when we're interfacing with an API, we're sending an HTTP request to them and maybe like posting a JSON, some JSON information in a way that it expects, and then we're getting JSON back.
Yep.
Okay, cool. Thank you.
Yeah, and like I said, most modern APIs are going to be using JSON. Some are going to be using XML. Like some format, some might just use their own format that they've decided to use. Like that is the choice that they've made. People have settled on JSON as kind of in modern times. Like people have settled on JSON because it is lightweight. There's a library for essentially every single modern programming language you're going to be using, and it's just something that people can use and just understand pretty simply. Tyler,
I guess that was also part of my question. You said that most APIs are going to have a JSON library. Where does that library live, and what does that consist of?
So that belongs in your programming language. For example, like in Ruby, when we do we require JSON that gives us access to the JSON methods, much the same way that like you require in a gem that gives you extra like other methods you don't normally have. Does that answer your question?
Yeah, thank you.
Cool. Let us take a 6-minute break. Let's be back at 10:40, and we're going to take a look at some more JSON a little more in depth. All right, it's 10:40. So let's kind of recap, right? So a JSON data structure is a string representation of either a single JavaScript object or an array of objects or other values. And because they operate similar in the way we operate with hashes, objects are made up of name value pairs. Important thing: keys must be double quoted and followed by a column. Not a column, a colon. Common mistakes that you will do working with JavaScript JSON objects. You will use single quotes instead of double quotes. You will not use quotes at all because you're used to not using quotes in Ruby. You will have a trailing comma somewhere where comma does not belong. And you will try to use like the \n to break a string. And those are ways you'll mess up JSON. There are probably others, like goodness knows I've broken JSON in many different ways because of like you all have seen me type, you've all seen me draw. Like this is life. And so what we're going to do is that we're going to look at how we can play with JSON and manipulate it directly. You can see my terminal, yes, hopefully. Cool. And we're just going to show you like it is pretty straightforward to use JSON in our thing. What I want to do is that to make sure I have access to it, I'm going to require JSON, and it says true, means it's able to load up the JSON stuff fine. And what I'm going to do is that I'm just going to do my hash equals hello, goodbye. And we see I've just created a regular Ruby hash. And we can verify that by doing my hash.class. We can see that's a hash. And what we can do is that we can use our JSON library to turn that hash into a JSON object. So I want to use puts json.generate my hash. And we can see that it converted this into valid JSON for me. So we can do my, oops. If I set equal to my JSON, we can see that is a string. JSON is just a string. All we're doing is converting a Ruby hash into essentially a very strictly formatted string. We send this information out, and whoever receives this information is just going to parse this back into some other into some form that it can understand. Like usually it's going to be something hash-like, because the idea of a hash is going to be something that's universal to most programming languages. And usually, you are comfortable, hopefully at this point you are comfortable working with hashes where like this is something easy for you to work with. And the same thing with any other developer is that when they get a JSON object, they are going to convert the JSON into whatever their local equivalent of a hash is and work in it that way. I want to note that some languages don't call it a hash; they call it a dictionary. So you can understand, like, when people are referring to dictionaries, they are also referring to hashes. The reason for that is that, like, in a dictionary, there's a word and definition. It's like a key and a value. That is why it's called the dictionary. Cool. So what we can do is that I want to demonstrate that we can nest values in JSON. We can put arrays, we can put values, we can put strings. And what I'm going to do is that I'm going to copy paste this, because once you see this, there's no way I'm going to type this correctly in the first try. And this is JSON right here. This whole thing is JSON. It's just a single object for a Jennifer Johnson that lives at 641 Pine Street. They have a phone. They have a phone that's true. You can see it's a Boolean. They have age that's 50, and they have pets, which is an array of a cat, a dog, and a fish. Any questions about this JSON object that I've just kind of pasted here?
I got a quick question. That syntax that you use, that JSON, when you convert,
which syntax?
Excuse me, the underline under JSON. Did you put that in, or was that generated because you had required in JSON? Up above, say line
like
4 of the pry session, yes.
Mm-hmm.
Did you?
Why is the underline?
Yes. Did you underline it, or did that happen automatically since you required JSON?
That happened automatically because I required JSON.
Okay, cool.
Yeah, that's a good question. I've never actually kind of wondered why it underlines things and sometimes doesn't underline things. I've just always accepted that. That's the way it looked like.
I got a question.
Yeah.
Let's see. Just kind of an observation / clarification. I noticed that the Boolean value is not in quotes, and neither is the integer for age or phone.
Yeah.
But that whole hash is also within quotes. So does that still? Okay. So even, okay.
Yeah.
Are you talking about the single quotes on the outside? That's what I was going to ask about.
Yeah.
Yeah. The single quotes on the outside, you're saying like this whole thing is going to be one big string. Like we could have made the outside quotes also double quotes, but you can see here that's a string. So we do person dot class. It's going to be a string. So we've shown you how to convert from a Ruby hash into a JSON object. This is a JSON object. And what we're going to do is that we're going to go the other way around. So generate makes JSON, parse makes hashes. And we do parsed person dot class. We have a hash. We do parsed person name. That's going to be Jennifer Johnson. And because you see that in quotes, it's going to be a string. We can do phone dot class. That's a true class because it's true. But that's going to be like the Boolean true. We could do pets and that's going to be an array of strings. So we can see here that the JSON library in Ruby, what it's done is taken this complex string and parsed it away and mapped it over to its Ruby equivalent of objects. It saw those brackets, like, okay, those brackets, whatever in here is going to be an array. It saw that it was like literally the letters true, like, oh, that's going to be the true, the Ruby true, and not like a string true. It saw that 50 outside the quotes. It's like, okay, that 50 is going to be the number 50 and not like the string 50. Colin? Unmute yourself.
There we go. So my question with that is, do you need to be careful when you're actually trying to pass strings based on what symbols are in strings?
Not in my experience, I've not had to be too careful because I just work with it in a hash the way I normally work with hashes and let JSON handle the rest. If I make sure my hash is good, I don't have too much to worry about.
Okay, cool.
Tyler?
Is this JSON syntax specific to Ruby, or is this how it looks?
No,
in all languages?
JSON is universal. Like it is the job. It is a subset of the official like JavaScript object guidelines.
Okay,
so
then
it is going by that.
So then, if you took this same exact thing in JSON in like Python or something, and parsed that, it would appropriately parse it into Python.
Depends on your interpretation of appropriately.
Okay.
Like it, Python might do things a little differently, but it's going to be consistent across Python. So people in Python are going to be like, this is how I operate in Python. It's going to be normal for them.
Okay.
So like I can't speak as to like the nitty-gritty details for every single different language out there, but like I think it is relatively safe to presume that whoever created the library for that language has made like the best choices for that language.
Okay, cool.
And that they understand whatever nuances that they may have to deal with. Mike?
So information is sent around the internet in these JSON packages, right?
Strings. They're just strings.
Strings. So does that mean that all of the HTML that comes through, all of the CSS, everything gets sent in this package that then gets parsed out into what you see on your page?
No. HTML and CSS are still strings. It's just a different format of strings. When computers are talking to each other, like I just want data, they will talk to each other in the language of JSON.
So this is how it says the data, not the actual like views. Okay.
So like for views and things like that, those are set in HTML because the end user is going to be a human being. When a computer is doing it, it knows the end user is going to be a computer. It's going to send it in JSON. It's like I am speaking to you in English because I know you speak English, and you would prefer to speak in English. Whereas, like if I were speaking to someone that spoke French, I would choose to speak in French to them because that is the best way to communicate for that person. And we would essentially tell like the computer, like I want a response back in this language. So like there are ways you can set it up so that if a human being with a browser hits like a certain URI, they get that HTML, CSS, and the view. And there's a way to set it up so that if a computer making an API request the same URI, you can tell like, oh, this is a computer, I'm going to send them JSON instead. Cool. Other questions as a whole about everything today? I kind of want to reiterate, like this is just this is an introduction. So like this is not information I'm going to use in module 2. We just want you to start thinking about JSON and see it and get the language down, so that it is not coming at you cold in module 3. Module 3 is going to be essentially all APIs, and we want to give you a kind of for lack of a better term, a head start, because honestly, consuming and building APIs is like super hard, and we want you to have like every single opportunity to like have this, even if it's like a little bit of this sinks in today, like it's going to pay off for you whenever like you hit module 3. Time is meaningless now. I think I saw this hilarious tweet of this guy talking about working from home his kid got very upset that he didn't he wasn't able to look at his arts and crafts because he was working. And his kid starts like bawling. He says, "Mondays aren't real." I'm like, I feel you. Tony.
Just really quick, something I noticed staring at the screen. Are there any nuances between accessing the parsed hash with strings or symbols?
Yeah. So you notice here that when we have
Sorry,
this, no, it's not a can of worms. It's a very good question. The comes from me, like, how am I going to phrase this? You see that when we have this parse person, we are accessing the hash through the strings, which is kind of like, who wants to hit that quote? The shift and the quote? No, nonsense. Usually what I will do, oh goodness, person. Give me a second. I'm just trying to find this. Oh, yeah. You can do this. Symbolize names true. And now you can see that these are symbols instead of strings.
Nice. And would you do that as a precursor for everything?
Yeah.
Awesome.
I don't want to deal with strings. Like, I'd always rather deal in symbols. You always, in general, you want to deal with symbols over strings. And so that's how you convert it. I just had to remember the syntax.
The parse method is reminiscent sort of the CSV write method that we did in Mod 1. It seems to function similar.
I mean, the thing is that I hope that, like, and that's a very good point that you make, Tony. Like, the idea here is that the way we've laid out and the way we've taught things is to kind of really illustrate you that we've created applications where we can strip out the data source and it does not matter. When you wrote you did football, right?
Yes, football.
Right. So what was your data source in football? CSV, right? That was your for lack of a term, database.
Sorry, a really nasty CSV. I think.
Yes, fair. To be fair, a less than optimal CSV. And the thing is that in football, you kind of wrote your own ORM. You wrote your essentially an active record equivalent, correct? To like do these finds and things for you.
Yep, absolutely.
Right? And so now we move you to Rails, where instead of the CSV, you have whatchamacallit, the Postgres database, and you have Active Record, which is this ORM that you're using instead, right? That's kind of next step. And well, that is the next step. And the step after that, which we're kind of slowly going to move you towards in 3, is that, like, let's say, like, we don't have a Postgres server anymore. You're grabbing it somewhere off the web. Now you need to make this interface for it. Okay. This is like, from when we think about the big picture, this is why we have MVC, where, like, essentially, what if we decide tomorrow, it's like, hey, guess what? You're no longer using the Postgres database for your apps. You're going to use this API instead. This is why front-end engineering exists, where we can fully divorce the front end from the back end. Like, we want to show you that, like, we can separate these two things, these two kind of like silos, and these two halves of apps completely, and it still works. And we really have to change very, very little.
Dope. Yeah. Just one last follow-up to it, since we're on the subject. So would you say that it's pretty standard practice to house or to store what you pull in from APIs? So in other words, instead of this data feeding the application the way it did football, it actually just feeds our database and then populates our database? Or
it depends on the situation. Some companies would be like, you are not allowed to store things locally. That will be a part of their terms of service, and like, they will sue you if you store things locally. The second part, one of the big ideas of why you don't want to do that, is that perhaps an API will have more up-to-date data. For example, the weather. do you really want to store? Well, I guess if you have to, you'd store the weather for like yesterday. But do you really need that? No, I don't want yesterday's weather. I want like now.
Okay, so it's sort of like having constant access to the data as opposed to like snapshots of it in time.
Exactly. It's kind of like you get what you need and you get like as you need it. Like for example, like Wikipedia. Do I download all of Wikipedia from my browsing? Like no, I go find the article what I want when I need to learn something, and when I do that, I automatically get like the most up to date information. It's kind of like the difference between an encyclopedia and Wikipedia.
Roger.
Right.
That makes total sense. Thank you.
Yep. Like encyclopedia is like I had to move with an encyclopedia once. That was one, not fun. Two, like why am I carrying around like a decade out of date information, right? Whereas I can just access it when I need to. That being said, there are complications around this. What if my internet's down? What if the API goes down? Right? These are other considerations you have to take into consideration. Other things you have to take into consideration. But again, like this is like some of the bigger picture ideas.
Roger.
Cool.
Thank you.
Yeah. Other questions as we wrap up? Tyler.
Is there a resource where we can find all these public APIs?
Yeah. Number one, it's like Google free public APIs. Programmableweb.com has a good directory of them. I will warn you that the good ones are never free. I'll give you an example. I wanted to have some fun, make like a horoscope astrology app, and I found an astrology API, and they were charging $10,000 a month. And I'm like, that's a lot of money for an astrology API. But at the same time, I think about like, they're probably getting that money. Like someone's paying that. They're not just,
So that's insane to me.
Yeah.
But
someone's figured out how to monetize it. So
in most apps that we would build, we wouldn't be relying on free APIs, would we?
It can.
Okay.
Like a lot. Usually what they'll do is that they'll have apps that like kind of like rate limit, like how often you can reach it. Like in module 3, one of the APIs you'll be working with is ProPublica. ProPublica is a nonprofit that does a lot of new stuff, and the API we'll be using is their government API, which gives you information about your elected leaders free of charge. Some people just make it for fun. Like, for example, my HogwartsAPI.com. I'm not going to charge for that. That's just something I did for fun.
Awesome.
Cool. Anything else? Awesome. You all are set for the day. You got some work time. You got PD. I'll get these videos up for you when I can, probably by the end of the day. But we'll be around on Slack if you need it. Toodles.
Thank you.
Thank you all.